Hello, welcome to another session on embedded system design. In this session, we will be discussing about memories and different types of memories, what we use in the embedded systems. So let's begin. So what is a memory? Memory is basically a storage device which stores the information and that can be read or recalled as and when it is required. So operation happens through basic three fundamental stages. That is, the data has to be encoded into a proper format, and then it will be stored, and then as and when required, it will be retrieved. So encoding, storage, and retrieval are the three stages in which memory operates. Encoding actually is needed so that the retrieval becomes easier. For that purpose, the encoding is performed so that the memory will operate in a proper format and data is also stored in a proper format in which it can be easier to retrieve the data. So in embedded system, basically we use two types of memories, and they are also known as primary memory in computer architecture. So that is, one is RAM, random access memory, and another one is ROM, read-only memory. These are the two common types of memories which we'll be using in most of the systems. The operation of these two memories is quite different, the way they operate, and of course the performance is also different from each other. As the name itself suggests, random access memory. It is used to store the data during runtime. Therefore, it is sometimes referred as a data memory in microcontroller context. So it is basically a random access memory. Next one is ROM, that is read only memory. This one is used to store the program. As RAM is called data memory, ROM is called code memory in the same context. As it is used to store the program, it is called code memory. As RAM is used to store the data, it is called data memory. Generally, we call them RAM and ROM. Only in microcontroller context, we refer to them as a data memory and code memory. Now we'll see what are the different types of RAM we have. Before going to that, let's understand what exactly a RAM means. As the name itself suggests, it is a random access memory. That means the location in such memories can be accessed randomly. When I say accessed, it includes both read and write operations. As we can access any random location required in the address space, we refer to such memory as a random access memory. The circuitry will be designed in such a way that given the address, we will be able to access any memory required, which is available in the address space, of course. Then this is a volatile memory. What is the meaning of volatile memory? Volatile memory means the data which is available or stored in the RAM is lost if the system is reset or power is switched off. In that case, RAM cannot store the data. It will lose the data, whatever it is having. And when we again reset the system, again the entire RAM will be blank, and again it has to be loaded with the new or a fresh data which will be used for the execution. So that is a random access memory. So we have three types of random access memories. One is SRAM, which is a static RAM, DRAM, dynamic RAM, and NVRAM, non-volatile RAM. We will discuss each one of them in detail, why they are called as static, dynamic, and non-volatile. Let's begin with static RAM. So here we can see a static RAM. So static RAM comes with a different number of transistors. There can be a 4 transistor RAM, there can be a 6 transistor RAM. Again, there are 8 transistor RAM also available. So basically this circuit which is shown here represents one bit of data. this particular circuit is used to store 1 bit of data. As we are using these transistors to store the data, this is also referred to as a electronic memory, which is based on latching circuit. On the right side, you can observe a latching circuit containing M1 and M2 transistors. So in the center, there is an orange circle which shows two latches cross coupled to each other. These latches which are cross coupled will actually store the data or the bit of information. Whereas the blue circles what we see, that is transistor M5 and M6, they are called as access transistors. That means they will be used for accessing the data which is stored in the latch, which is cross coupled latch. So if you closely observe, the cross coupled latch are CMOS, complementary semiconductors, that is CMOS technology, that is complementary metal oxide semiconductor transistors. So they will be operating in a complement format. So M4 and M3 are one pair and M1 and M2 is one pair. So they are complementary circuits. So now when we want to access a bit of a data, okay, first we have to enable the word line, which is a horizontal top line. You can see it written as a WL. That is first activated, and then once it is activated, M5 and M6, these two transistors will get into a saturation, that is on state. So they allow the current to flow through them. So whatever the data is stored in the latch, that data will flow to a vertical line named as BL, that is bit line. If you observe, there are two bit lines, one on the left side, one on the right side, BL and BL bar or a BL dash. That means BL and BL dash are inverse to each other. If BL is having 0, then BL dash will have 1. If BL is having 1, BL dash will have 0. They are inverted to one another. Now to read the data, actually only one, either BL or BL dash can be read. Only one line would have been sufficient to read the data. But if we see the overall matrix of these cells, this entire circuit, what we are saying is called as one cell, which stores a bit of data. So there will be a lot of cells which are arranged in the matrix format. So usually word line will be of 8 cells. It will connect totally 8 cells in the horizontal pattern. Whereas in the vertical, it is a very, very long wire. That is BL and BL dash will be a very long wires. And we know that by basic electrical principle, when wire goes very long, its capacitance also increases. That is referred to as a parasitic capacitance. Now due to that capacitive effect, there is a delay in the data flow. So that causes a additional time to read the cell. So by driving two lines BL and BL dash, the circuit is getting optimized to read so that the data can be read comparatively faster. However, SRAM are much faster memories, but we can see that there are around 6 to 8 transistors. Here it is a 6 transistor circuit what is shown. So one bit of a storage requires 6 transistor, which is very, very expensive in terms of fabrication. So this type of memories are used wherever we need a very fast operations, such as cache memories on chip of the CPU. We know that whenever we design a CPU, on the CPU there will be a cache memories L1, L2 or like that. So those cache memories will be designed and fabricated using a SRAM, static RAM. So these static RAM have an advantage of faster access. Again, this will operate in three stages: standby, reading, and writing. As the name itself suggests, standby is idle state. Reading and writing are respective read and write cycles. This type of memories will consume more power, but they are very fast. So they generate a lot of thermal dissipation. As they consume more power means it will generate more of heat. So a proper ventilation is required for such type of memories. So it is not preferred to have a very large size of this type of memory. So this is a very limited memory and used wherever we need a very fast operations. Only there SRAM will be used. We have another type of RAM, that is DRAM, that is dynamic RAM. Now this type of memory uses capacitor to store the data instead of a transistor latch. So typically a metal oxide semiconductor is used. That technology is used to use the access transistor, and capacitor is used to store the data. Even capacitors are sometimes implemented using a transistor itself. But here, if you observe the matrix of these cells, each cell has only two components, one transistor and one capacitor. So in a given area, we can have more number of cells. That means the density of memory is very high compared to SRAM. In the SRAM in the previous slide, we saw that it needs at least 6 transistors or at least 4 transistors. So that is very expensive in terms of footprint or the area what it consumes for the one bit of data. Whereas here we have only two components, one transistor and one capacitor to store a bit of data. But here this capacitor start discharging when current is not supplied. So even if you are storing a value in the capacitor, it may lose the value after some time. So to make the cell to retain the data what is stored in that, we need to refresh these cells frequently. So the period for which the capacitor stores the data or the frequency at which we need to refresh these cells are called refresh cycle. So we need a separate circuit for refreshing these memories. So again we have a circuits of decoding the given address and selecting a particular word line, and when the word line is selected, then a particular column will be read from the data select. You can see a data selector is there and a latch. At the bottom we can see a latch and a data selector, and on the vertical side we can see there is something called as RAS, which is row access. So that is used to enable the particular row and the data will be read from that. Row access signal. RAS means row access signal. So those signal will be used to enable the particular row and then read the data from a respective columns. So which row has to be activated and how much voltage to be supplied, that all will be taken care by the circuit which is designed in the periphery of the memories matrix. So as the density is very high, because of that the cost per bit, that is the expense what is spent for storing one bit, will be very small or very less. So this type of memory is used when we need a very large or a huge amount of RAM. Especially primary memories of our computers or laptops will be using DRAM, and as we know the on-chip memories are used SRAM. Other than this, we have another type of memory in a RAM itself, that is non-volatile RAM. In the previous two types, that is SRAM or DRAM, in both the cases the data which is stored in the RAM will be lost on reset or power off. If you switch off the power or if the system is reset, then whatever the data is stored in such a RAMs, that data will be lost. Whereas in non-volatile RAM, that is NVRAM, this retains the data. That's why it is called as non-volatile RAM. So it will hold the data even if the power is switched off or turned off. So how does it do that is, the NVRAM ICs will have an on-chip power backup. It will have a small battery which is embedded in the IC itself. Whenever there is no external power supplied to the IC, the internal on-chip battery which is provided, that supplies the power for the NVRAM to retain the data, whatever the data is stored in them. Again, NVRAM can be designed based on two types, that is either using a static RAM, or NVRAM can also be designed using a E2P ROM. What is E2P ROM? We'll see in the coming session. SRAM we have already discussed. EPROM or double EPROM we'll discuss in the upcoming slides. So this is a NVRAM. So RAM has three types: static, dynamic, and non-volatile. Static is an electronic memory. Dynamic is also an electronic memory. NVRAM is also an electronic memory. All three RAMs are electronic memories which use transistors to control the data available or store the data. SRAM completely uses transistors. DRAM uses a transistor and a capacitor. NVRAM is again based on either SRAM or E2P ROM. SRAM again uses a transistor to store the data. Now we'll see another type of memory. Before that, we'll just have a comparison of SRAM and DRAM. In the SRAM, the information stored is lost once the power is switched off, and same is in the DRAM, and it needs a capacitor discharges even after it is switched off. That means SRAM loses the data instantaneously when the power is removed, whereas DRAM retains the data for a very small period, because as the data is stored in the capacitor takes some time to discharge. So during that small amount of time, the data will be retained. After that, it will lose the data because there will not be any refresh cycle once we switch off the power. And if we don't refresh DRAM, then the data will be lost. As we already discussed, in SRAM, data is stored in transistors, that is in the latches which are cross coupled, and in a DRAM, it is a capacitor which stores the data. And SRAM does not need any refresh cycles, as it is stored in the transistor. It will be stable state, so it does not need any refreshing cycle. But capacitors need a refreshing cycle to retain the data. So SRAMs are much faster compared to a DRAM. At the same time, SRAM are expensive compared to DRAM. So DRAM are cheaper but slower. SRAM is faster but expensive. So SRAM are used wherever we need a low density memories, and DRAM are used when we need a high density memories. Whenever we need a high density means the number of cells per given area will be very high. That's why it is called high density memories. So SRAMs are mostly used in the cache memory implementation, which is on chip in the CPU itself. And DRAMs are used in the primary memory in the computer, which are separate peripherals interface with the processor. Now we will see what is ROM, read-only memory. So data stored in the ROM cannot be electronically modified after the manufacture of the memory device. ROM, basically what happens, during manufacturing itself, the data will be stored, it is hardwired, and that data cannot be changed after device is manufactured. So these type of memories are useful to store the data or the information which are not changed throughout its life cycle, such as a configuration or a firmware. Firmware are basically nothing but a configuration information of a particular hardware. So that all information will be stored in the ROM. However, ROM also can be modified rarely. We'll see how that can be done. But a basic fundamental ROM cannot be modified. A later versions of the ROM can be modified. So it strictly refers to a memory that is hardwired, such as diode matrix or a mask ROM. These are all hardwired. That is, they are ones and zeros. Whatever the information has to be stored, that will be decided during the manufacture itself, and during the fabrication process, the data will be stored. ROM is again an integrated chip or an integrated circuit. It's an IC. So there are for 3 or 4 types of ROM. 3 types basically. Fourth one is again a version or a modified version of E2PROM, which is called as a flash memory. So we'll see that also. We'll see it one by one. So first in PROM, that is programmable ROM, also sometimes referred as a one-time programmable. Then EPROM, that is erasable PROM, erasable and programmable ROM. Then EEPROM or E2PROM, which is electronically erasable and programmable read-only memory. And last one is flash. We'll see each one of them one by one. So first one is programmable read-only memory. This digital memory where the contents are changed once after manufacture of the device. In the basic ROM, the data cannot be changed because they are hardwired, but the revised version, that is the PROM, that is programmable read-only memory, gives option to program it only once. So these devices are also called as one-time programmable memories. Only once we can program the memory. If the program is not working properly, then the hardware has to be changed. That memory chip is waste. Another memory chip has to be programmed again after modification. So before putting the program into a PROM or a OTP, we should make sure that the program is correct. This type of memory is used because it's very secure. Once the program is dumped or the burnt into a memory, then it cannot be changed by any other means. So the data what is stored in the PROM is very much secured. That is the reason why PROMs are used for firmware or configurations. Once if the configuration is not required to be modified, then whatever the programming has to be done in those particular ICs, that will be done at once by the developer, and then that will be put into the machines. Especially in the washing machine or the microwaves, there usually the programs will not change. So there will be a particular configuration which will not change. So those configuration will be put on the OTPs or PROMs. So it's a permanent data. Devices store the permanent data. As we said, it is a low-level program such as firmware or a microcode. Blank PROMs chips are programmed by plugging them into a device called a PROM programmer. We have specialized devices used to program such memories. End user cannot do any changes. Only developer can program it once. Initially, by default, PROMs comes with all the bits reading as 1. Then it has to be changed to 0 wherever it is required. By default, all the cells of the PROM will be 1 when it is manufactured. So there will be a fuse which will be like structure, fuse like structure, which is available. So that has to be burnt to make it 0. So burning a fuse is nothing but writing a program into that. So we know that once the fuse is burnt, we cannot fuse it back. Once it is burned means it is over. It cannot be made as an original fuse again. That's why these are all one-time programmables. The next type of memory is EPROM, that is erasable and programmable read-only memories. These type of ROM use a floating gate transistor, which is shown. A diagram is also shown there. There are two gates. One is a control gate, another one is a floating gate. So that floating gate gives an option to erase and reprogram. So to erase the content of these cells, the cell has to be exposed to an UV rays. So UV rays, basically a mercury vapor lamp which generates UV rays, we can expose it to that, or even if it is exposed to open sunlight, in sunlight also we have a UV rays, there also it can be erased. Depending on the intensity of a UV rays, the time taken will be changing slightly. Usually the time taken to erase such memories is 5 to 30 minutes. That means it's quite a long process to erase the data. To expose the memory to UV rays in such ICs, which is EEPROM ICs, on the top of EEPROM IC a transparent coating is given through which the UV rays can be passed. So the IC circuit can be seen through that. So UV rays also can pass through that. So that will erase the content of the EEPROMs, and once it is erased, then again they can be reprogrammed. So as I said, EEPROMs can be easily recognizable by the transparent fused quartz, or a late model resins. In the later versions, resins is used. Transparent fused quartz was used originally. Window, as I said, on the top there will be a window on that IC, that is the package. So through that UV rays has to be passed. The erasing is not electrically programming process is not electrically irreversible. That means whenever we want to erase it or change the content, then you have to erase it using a UV rays. Only program can be done using electrical. Reversible cannot be done using electrical process, or electrically we cannot reverse the content of the memory cells. Only UV rays are able to cause it by doing a ionization through silicon diode, which allows the stored charge on the floating gate to dissipate and reset the memory cell. That's why a floating gate is used in such memories. Then another memory we have is E2PROM or EEPROM, that is electronically erasable and programmable read-only memories. So as the name itself suggests, they can be erased and programmed both electronically. We can either erase it electronically or we can program it electronically. So again, these are also organized as arrays of floating gate transistors. So those floating gate transistors are given a particular voltage to erase the content of the particular cell. So there is a particular signal, a special signals has to be generated with a particular voltage. A normal logic voltages what we use for read or write operation, that they will not affect the floating gate. So a specialized signal has to be generated with a higher voltage. Only that will be able to erase the content or reset the content of the memory cell. Otherwise, normal operation of read and write does not change the value or the bits stored in the memory cell. So as we can electronically keep reprogramming, so there is a limitation. So usually it will be a million operations for a particular cell. 1 million operations we can perform on a particular cell. Again, these EEPROMs can be accessed either serially or parallelly. There are two ways in which they can be accessed. So as the name itself says, when we access them serially, it is bit by bit which is accessed. And when we access parallelly, all the 8 bits will be accessed at a time. For serial access of E2PROM, usually SPI, that is serial peripheral interface, or I2C, that is integrated chip communication. These two will be used to access the data in case of serial communication. Or in the parallel communication, all the bits of the E square PROM will be read at a time. That's why it's called as parallel. A small modification of the same E square PROM, we refer to that as a flash memory. These flash memories are nothing but a E square PROM only. The only difference between the E square PROM and the flash memories is that the E square PROMs are accessed byte by byte or a small blocks of memory. Usually it will be byte by byte. We will be able to modify in the E square PROM. But in the flash memory, it is not byte programmable. It is block programmable. A particular block of memory is modified at a time. So the operation will be much faster because a block of memory will be accessed. But as the block of memory is accessed, again that itself becomes a limitation of flash memory, that it can be erased only by block, setting all bits to 1 in particular block. We cannot change any one particular bit or a byte of a memory address space. All the bits will be made to 1 or all the bits will be made to 0. So these flash memories will have around 1 lakh cycles or 100,000 cycles of a lifetime. So these are some different types of memory which we use in the system. Again, in the coming sessions, we'll be discussing about the serial communication protocols and other concepts of embedded system. Thank you.